Let's talk about Lesson 7, Activity 3, Question 8. In this activity, I am completing a proof, and given that line AB is congruent to KL, that line AC is congruent to KM, that angle A is congruent to K, that angle C is congruent to M, and that triangle KLM is the image of triangle ABC following a reflection, I need to prove that triangle ABC is congruent to KLM. So this is a lot of information to digest at first. Let's take it step by step, and you'll see in your workbook you have this same question, and they've actually already provided most of the statements and reasons for you. You just have to finish off the proof. However, for the purposes of this example, I thought it might be more helpful for us to break it down line by line. So, with any proof, we have to begin with what we're given. So, I would just start by copying down your statements, your givens. So I'm going to say that AB is congruent to KL, and I'm just again going to copy down what I've already been told. Now, one more thing as I go through here, it's going to seem kind of straightforward and simple because, of course, I've had the opportunity to kind of pre-plan, and in textbooks and in other examples you see, the instructor or just the lesson has already pre-planned, and we kind of know what's happening behind the scenes because we've already worked on it. Now, doing proofs is something that takes practice. It's something that will get easier as you go. And it's not something, it's like doing a maze. You often don't solve the maze and turn all the right ways the first time, but you can still get through it with a little bit of trial and error. And doing proofs is kind of like the same thing. So I've copied down some of my statements here, and again, my first step in any proof would be to copy down all of the statements that were given to me because that information is probably going to come in handy. So now let's examine this. I mean, I know I wrote it down, but do I actually understand what these given statements are telling me? Well, they say that AB is congruent to KL. AB is congruent to KL. The definition of congruency is something that's been discussed a lot. I discussed it in my last video, so if you're not sure what it means, be sure to pause this video now and go refresh your memory. Moving on, AC is congruent to KM. So AC is congruent to KM. And I'm just marking these congruent line segments with tick marks. It helps me stay organized with my information. You can see that I gave one tick mark to AB and LK to match them together, 2 tick marks to AC and KM to match them together. This is just something that helps my brain stay organized. It's not something that you need to do if it isn't helpful to you. Okay, so that's pretty straightforward, but then they also told me triangle KLM is the image of triangle ABC following a reflection. And I wrote it a little short here because I just didn't really have space, but it's important when you're copying down your own statements, make sure to write out that full given statement because you never know which aspect of it is going to be the part that you rely on to justify statements that you make in the proof. So triangle KLM is the image of ABC following a reflection. So in other words, ABC was reflected and triangle KLM is the result. Now, playing on that, I am going to make a claim that BC is equal to LM. And you may be wondering, why did I go there? Why am I talking about these segments? Well, something that occurred to me is that I've made claims about 2 sides of each triangle, but nothing's been said about that remaining side. And so chances are, if I'm trying to do something where I'm making a proof about triangles, I'm going to have to involve all 3 sides, right? And again, this is something you can play around with. Now, BC is equal to LM. And the reason I'm saying that is because a reflection is an isometry. And an isometry just means something that I'm able to manipulate, and the relationships between each of the points are the same. So any point that I pick on triangle ABC, and then any second point I pick on triangle ABC, whatever distance between any 2 points that I pick, that relationship, the integrity of that is still intact in the triangle, in the new triangle, the image. So, in other words, all I'm trying to say is isometries preserves the distance, between those two ends. Now, if two segments have equal measure, which is what I just claimed in my last statement, and I backed it up with that reasoning. If if two segments have equal measures, what do I know? Well, that means that they must be congruent. If two segments have equal measure, then they are congruent. And that's pretty much just being drawn from the definition of congruence. So, my reason that is if two segments have equal measure, they are congruent. And again, I'm writing this all pretty shorthand. This is not something you want to do when you have the time and space to do it. This is just for the sake of shortening the video a little. Okay, so I've just established that BC and LM are congruent. Now, I've used up that information that I had about I called on that information about the reflection. At this point, I'm kind of stuck, but I haven't used up all the given information yet because they also gave me some information about those angles. So let's write that down here. Now, again, if you were doing this on your own, chances are you would have already copied all those statements into your top rows there where you had written your given stuff. I'm just calling on it now. So I know that angle A is congruent to angle K, and I know that angle C is congruent to angle M. So I'm going to mark that out on my picture. Again, just helps me keep organized. So angle A right here is congruent to angle K, and angle C, which I will put kind of a double angle marking on, angle C is congruent to angle M. Okay, and again, this was given to me. So what can I do with that? Well, I can kind of play the same game that I did before. So remember, last time I knew that two of my three segments of triangle ABC were congruent to their corresponding parts on the other triangle. And I used that to kind of establish that the third side was also congruent. So I'm going to do the same thing here. I'm going to claim that the measure of angle B, is equivalent or equal to the measure of angle L. So I use this, I'm able to establish this for the same reason. Because a reflection, in this case, rather than talking about isometries, I'm going to say a reflection is rigid. So once again, calling on my information about that reflection. I know that these measures are equal because reflections are rigid, and rigid transformations preserve angle measures. So because the reflection is rigid, and that preserves angle measures. So that means that if these two have the same measure, then they must be congruent. So angle B is congruent to angle L. Because if two angles have equal measure, then they are congruent. Okay, so let me mark that. All right, so I know that segment AB is congruent to LK, segment AC is congruent to KM, segment BC is congruent to LM. Angle A is congruent to angle K, angle C to angle M, and angle B is congruent to angle L. Finally, I can claim that triangle ABC is congruent to triangle KLM by the definition of congruence. Remember, congruent things, the angles, the measures, the segments, right? If I prove that each segment and each shape is congruent to its corresponding piece and each angle is also congruent, then I can claim that the triangles, the shapes themselves, are congruent. So quick recap, once again we began by establishing our given information, and then we called on definitions to help move us along. So I knew because of my reflection, I know reflections are isometries, and that allowed me to establish that my two segments were of equal measure and were congruent. Using the same reasoning, I once again called on the fact that this was a reflection, and because reflections are rigid, they preserve angle measures, and I was able to establish that angle B and angle L were congruent. Once I had gathered all this information, I was able to call on the definition of congruence to establish that triangle ABC is congruent to triangle KLM.